Hello again. Today we're going to continue talking about the elimination method, except we're going to look at the harder ones where we have to change one or both equations. So we've got an example here. All right, and now what's different from today and yesterday is that if I were to add these two problems together right now, or subtract the two problems, I wouldn't get either letter to eliminate or cancel out. So it wouldn't help me to have a third, more challenging problem that has both letters still in it. The idea of adding them together is to make one letter eliminate. So since one of the letters won't eliminate, we can't use elimination method yet. We have to force it to happen. So the first thing we have to do is we want to find the least common multiple for each variable. All right, then select whichever pair looks easier. So for example, for 2x and 4x, my least common multiple would be 4. Well, that'd be easy because one of those numbers is already 4. And it'd be pretty simple to turn a 2 into a 4 with either times by 2. Now, on the other pair, 3 and 5, their least common multiple is 15, meaning you would have to change both equations. But it'd be easy, times 3 by 5 and 5 by 3. So again, we would easily be able to do it, but it would require more work, changing both equations. Whereas the x's, I would choose that as the easier pair because one of the numbers is already a 4. All right, now we're going to multiply one or both equations, again depending on what we've chosen, by any number to force opposite coefficients. So we're trying to get is opposites, 1 plus and 1 minus. And just a second ago we said we were trying to turn these x's into 4s. Well, this one here is already a 4. Don't change it. Don't change any of it. It's ready. But what we want the other one to have is the opposite coefficient. We want it to be negative 4x. Right now it's not negative 4x, it's a 2x. So what would I multiply it by to turn it into negative 4? Well, I would multiply by negative 2. If I did distributive property, negative 2 times 2x would make negative 4x. I just have to do it to all of those numbers. I also have to do negative 2 times 3y for negative 6y. And I also have to do negative 2 times 14 for negative 28. But if you've done it right, at this point, you should have the x's cancel out if you were to add the problems together. So if you took negative 4x and plus 4x, they'd turn into a 0. So that's our next step. We're going to add these equations together and solve. So if I do that, like I just said, those are going to cancel. The negative 6y plus negative 5y will make negative 11y. And then negative 28 plus 6 will make negative 22. So we solve that. It should be a one-step equation, dividing both sides by negative 11. I got a y answer of 2. Now substitute that back into whichever original equation looks easier to you, and you can't choose wrong. They will both work. We learned that yesterday. So I'm just going to pick the one that's on top, the 2x plus 3y equals 14 one, because again, I make mistakes with negatives, and that one doesn't have any negatives. So I'm going to replace the y with a 2. And the reason I'm doing that is because we just found out y equals 2 in this problem. So that means I got 2x plus 6 equals 14. So I'll minus 6 on both sides at this point. 2x equals to 8. 14 minus 6 is 8. And then I'll divide both sides by 2. And I have a final answer, 4 for x, 2 for y, written as an ordered pair. Let's try one more. All right, so this one here, first step, let's look at our letters. First off, let's look at x's. What would be their common multiple? Again, if you don't know how that works, you skip counting by 5s. You're skip counting by 3s. And you're looking for a number, the smallest number, that's in both lists, 15. So that's my common multiple for the x's. Now for the y's, 4 and 9. Well, again, what I do is I take the bigger number. I don't like making both lists. Just take the bigger number. Does 4 go into 9? No. Times a bigger number by 2. Does 4 go into 18? Nope. Times the bigger one by 3. Does 4 go into 27? Nope. Times the bigger one by 4. Does 4 go into 36? And the answer is yes, it does. And there's your common multiple. So my options: turn the x's into 15s, which means changing them both, or turn the y's into 36s, which also means changing them both. So there really isn't an easier choice. It's just about what you feel more comfortable with. I'm going to go ahead and go with the 15s because it's a smaller number. So I'm going to try to turn those first two equations, one of them into having a 15x and one of them into having a negative 15x. So let's take the top one. Let's make it a positive. So I'm going to times by 3 because 3 times 5 will get me my 15. That's going to be 3 times 5x. And then don't forget 3 times 4y also. And then don't forget 3 times negative 30. Now the bottom equation, I want that one to end up having a negative 15x so that those cancel out without me having to do any extra subtraction. Easy to make mistakes with extra subtractions. So I need to figure out, what do I times this 3x by to turn it into a negative 15x? The answer is negative 5. Just divide them instead. Opposite of divide, multiply is divide. So then multiply. Negative 5 times 3x would be negative 15x. Good, that's what I wanted. And then negative 5 times negative 9y makes 45y. And then negative 5 times negative 18 will make a positive 90. All right, if everything has gone the way we planned, these x's should cancel. And I end up with 57y equal to 0, which is fine. 57 times what makes 0? Well, times 0. Or you divide both sides by 57. And 0 divided by anything makes 0. So remember our final answer, we now have the y portion of that answer, 0. Now let's go back and let's find the other portion. So that means go back to whichever one of those problems looks easier to you and make the y equal to a 0. I picked the top one for no other reason than, again, it looks like it has fewer negative signs. And I am doing what this says. Change the y to a 0. So I'm going to do that. I'm going to change that y to a 0. That would cancel out. Leave me 5x equals negative 30. And then dividing both sides by 5. And I end up with negative 6. Alright, so again, these are a little bit more time-consuming. They're not impossibly hard, they're just time-consuming. It took us 8 minutes to do 2 of them. So I expect there to be the occasional difficulty, but they'll let me know if there is. Good luck.